Welcome to classes on physics. Today's class is dual nature of radiations and matter. It is higher secondary second year and lecture number 1. From the chapter itself, the name is dual nature of radiation and matter. Means dual means two, nature of radiation and matter. There are two properties of radiation as well as matter. Each and every one of you know the matter has wave nature and matter has particle nature. So also it is given by de Broglie later on will come from its relation lambda is equal to h by mv, where he relate the lambda with momentum. Am I right? So any objects has wave as well as momentum. So that waves of the matter is called matter waves. So the objects or the matter has wave nature is given by de Broglie, and it is known to you all matter has a wave and it is matter wave, and it is given by de Broglie. We will come it later on about de Broglie hypothesis. But dual nature of radiation or subatomic particle like electron, it is a bit hard to understand. So first of all, dual nature of radiation, that means it has particle nature and also it has wave nature. So before coming to the main topic of this one, let us first understand the key point which we need to understand before proceeding to the main contents of the topic, that is particle and wave natures. Now what is particle? Particle. So here, for your clear understanding, just I am differentiating the fact with the examples particles and waves. Particles are lump of materials, that is same type of materials fused in a fashion. Lump of material when moves as unity. During its movement, they become one unit. It is nothing but disturbance in medium and spread. Number two, it is confined in a specific area. If it is particle, it will confined in a specific area. It will occupy a specific area and it spreads out in space. Wave. Number three, it follows interference or diffraction, but it doesn't. Number four, sum of particle gives a constant value. 1, 2, 3, 4 particle, if you add up, you will get a specific value. But sum of wave either moves, sum of two or more waves, maybe more or less than the individual wave. There may be destructive interference or constructive interference. It may increase, it may decrease. Next, two particles cannot be placed in one place means one marble. If you want to place another marble over it, until and unless you remove the first marble, you cannot place. That marble is nothing but a particle. But two or more wave may coexist. These are the some simple concept from which you will get a simple idea about particular and wave. Now, the main bone of contention in the chapter is that the radiation or the light particle which has both wave as well as particle nature cannot be experimentally determined very easily. But here in the chapter you were given two things. One is photoelectric effect, and other is Compton effect. These two effects give you the proof that the radiation of light or light radiation has particle nature. Am I right? And we will bit by bit come with photoelectric effect and Compton effect in later stage, and we will explain that radiation with the help of this experiment. Radiation has particle nature. So you see that photo, what does photo, in short, later on we will come it and we will tell in details. Now what does photoelectric effect tells? Photoelectric effect indicates that when light interact with the matter, it behaves as if it is made up of discrete packet of energy. Here a term energy is equal to h nu is equal to nh nu is equal to packet of energy, and quantization of energy, a concept we will explain in terms of quantum mechanics then later on. The photoelectric effect indicates that when light interacts with the matter, it behaves as if it is made up of discrete packet of energy, and it is called quanta. And the light quantum has energy as well as momentum, which allows to associate particle nature, and this particle of light is called photon. So photon has particle nature. Why? Because it has energy. E is equal to h nu, nu is equal to c by lambda. So also E is equal to mc square is equal to mc into c. Mc is equal to momentum. So you take c below. So you are getting E by c is equal to p. So you are getting p is equal to E by c. So that photon has two things, one energy as well as momentum. So whenever you get these two things of photon, you will say the photon is nothing but a particle. Am I right? So with the help of photoelectric effect, we can say that photoelectrons or radiations which are consist of photon has two things. One is wave, two properties. One is wave property and other is particle property due to this fact. So some of the important properties of photon here, just I am telling the velocity of photon is equal to velocity of light, and equal to, it is known to you 3 into 10 to the power 8 meter per second. So also the relative mass equal to m, m is equal to m naught equal to 1 by b square minus c square. At rest v is equal to c and m is equal to 0. That is the mass of the photon at rest 0, because photon does not exist at rest. Am I right? Again, photon, the energy of photon equal to E equal to h nu. Again, the momentum of photon P is equal to E by C. Already I have shown you. These are the some properties of the photon. This will come on need while you will solving out the problem. So there are some types of the emission of the electron, that is thermionic emission and cathode emission and photoelectric emission and secondary emission. Out of this, I will just for your knowledge, I will talk about very little about the each and every content. Thermionic emission, that is metal, therm means temperature. When metal is heated and a thermionic potential barrier is produced, and electrons when cross this potential barrier, the electrons is emitted, and that emission of electrons occurs after heating of the metal. Next, cathode emission. When cathodes the potential in between the cathode electrodes where electric field is produced 10 to the power 3 V per meter to 8 to the power V meter inverse, then electrons are emitted out from this, and it is called cathode emission. And next is photoelectric emission. We will talk about this in details later on. And secondary emission, when fast moving electron strikes the metal surface, then this electron transfers some amount of energy to the other electrons, and the other electrons when get energy excess of the or cross the W naught work function. We will again get this term just now a bit later, that electrons will emits out. That type of emission is called secondary emission. So simple type of emission is thermal emission, cathode emissions, and photoelectric emission and secondary emission. These are the simple type of emissions. Here I am giving you some types of the metals and which metals from where you can very easily, and this time in entrance exam, NEET exam, a question from in physics appeared, and I will tell which was the question and what is the nature of the question. Sodium, potassium, rubidium, cesium, these are the type of the metal from which you can emit electron. Electron can be emitted with the help of visible lights, and these metals are called photosensitive metals. This year in the NEET exam, a question was given along with the cesium, cesium and other metal, and work functions are given, and it is asked from which of this below metal, from which of this below metal the photoelectron will be ejected very easily. Answer: the if the W naught, that is work function, is the less, the metal which has less amount of work function will very easily remove electron, or electron will be ejected out upon electron out when photo light of the visible lights falls upon it. Am I right? So sodium, potassium, rubidium, cesium, these are the type of the metals from which the electron can be ejected out with the help of visible lights. Hence, this type of the metals are called photosensitive metals. Zinc, cadmium, magnesium, aluminum, etc. Lot of other elements are metals are also there. These the photoelectron from these metals can be ejected out. Electron can be taken out with the help of ultraviolet light, or another heavy metals, those which from which the electron can be ejected out with the help of X-ray. And also there is a lot of metals is given in our books, but I am giving you the two examples. Cesium, where work function is 2.2 eV, or sometimes it is given 2.1 eV, and platinum 5.67 electron volt. So the work function of cesium is less, photoelectron will be ejected very easily, and work function of the platinum, W naught for platinum, is 5.6. it is highest, then it will take more time to eject out more radiation to eject out electron from this metal surface. In a very ordinary way, I have just have shown you a setup where a cathode and anode is attached to the emitter and voltmeter, and the connection is attached with the key and the battery. And here I have shown you anode as a collector and cathode as emitter. When light of suitable wavelength is fall upon the cathode, what's happen? The electron will eject out from the cathode, and electron will starts moving from cathode to anode, and potential difference is developed inside it. Hence, here collector potential and here emitter potential, and what's happened due to this, difference in potential, electron moves from cathode to anode and current starts from anode to cathode. Electron moves from cathode to anode and current develops or moves from anode to cathode. So there is development of current in the outside circuit due to evolution or ejection of electron from cathode to anode. So anode is, since electrons are being collected here, it is called collector. Here collector potential is designated here and this. Another important point is that the potential of anode can be polarized. It can be plus, it can be minus. You can change the potential. So upon changing of potential, we will get another type of concept. So upon this setup, we'll explain. So in a very simple way, I have some drawn you the collector potential and photoelectric current, where there is, it is collector potential, and here beyond O is the negative potential or retarding potential, and here photoelectric effect. If you draw this figure, we will find what you see here, that if you just on positive, if you see, when you move, when you increase the potential, collector potential, when collector potential is positive, means here it is positive, means here positive, at each and every point you will find, with respect of this point, you will find the amount of current is increasing. Photoelectric current is increasing. Am I right? So when the collector potential is increased or positive potential is increased of the collector potential in positive line, if it is increased, we see the photoelectric current is also increased. But at certain time we will find that at certain level the potential, when plus positive potential is reached at certain point, the saturation of the photoelectric current occurs. And from this to that point, if we increase further the potential, positive potential, there will be no change of photoelectric current, and that current is called saturated current. Now another important concept very often asked in the question, and this is very often you need to know to solve out the problem or boost up your concept. First you see that if you move towards this one, I have changed, I have told you that we can change its potential from positive to negative. If we now start decreasing the potential, and if you move in this way, so negative value of the potential, if you make it negative, negative and negative and negative, so whenever the potential of this collector potential is made negative, the less amount of electron will start approaching towards A. So on further increase and increasing, you will find a time when negative potential becomes at certain point, reach at certain point, there will be no current, because no flow of electron occur, because if it is more and more negative, at certain negative point of this potential, electron will stop approaching towards it. When electrons stop approaching towards it, the current stops. So the negative potential at which the photoelectric current stops becomes zero, that potential is called cutoff potential. Cutoff potential is called cutoff potential. So I have explained here saturated current, and I am explaining the figure where we have seen with certain positive value of the collector potential, along with the increase of the potential positive value, current increases. At over certain point it becomes the same, and if we increase negative value further and further and further increase, we will find at certain point the negative value of the collector potential with respect of cathode, the no current will flow in the outer circuit, and for this negative value of potential, it is called where there is no flow of current, is called cutoff potential or stopping potential. It is very important thing. Now we will explain first of all one thing with the help of diagram, and again this is the graph. This graph is very important for exam point of view and also for your boosting of your knowledge. Intensity versus photoelectric current. Now what is intensity of radiation, intensity of incident radiation, what is intensity maximum of, you may not have sound knowledge on intensity. Now again very important, and you will very often confused when short questions is given for this is dependent upon intensity, kinetic energy is dependent upon intensity of light, or photoelectric current is dependent upon intensity of light. A lots of things are used, and you may not, if you do not have the idea on intensity, what is intensity, you might not be able to give the correct answer. Now what is intensity? Actually amount of the incident radiation falling upon the metal, amount of incident radiation falling upon the metal per unit time, per unit time, per unit area, per unit time with respect of time. Mind that per unit area, per unit time is called intensity. If a light of same frequency fall upon the metal surface, if the time lag of falling the incident radiation is more, so more and more intensity is falling upon it. So if there is a time term is attached with it, then same frequency of light, when it is exposed upon the metal surface for longer time, it will have greater intensity. Now what will happen if there is greater intensity? Means if the intensity increase, which means the number of photoelectrons striking the surface of metal will increase. Am I right? That might have the effect upon the ejection of electron. More is the intensity, more will be the ejection of the electron. Am I right? Later we will come bit by bit. Amount of incident radiation falling upon metal surface per unit area, per unit time is called intensity. With increase in intensity, number of photon particle striking the metal surface will also increase. That is the main concept of intensity. Now why I have explained the term intensity, because intensity and photoelectric effect, it is a straight line. You increase the intensity, the number of photoelectron will increase, the number of photoelectron, if it is increased, number of the magnitude of current will also increase. So with increase of intensity, photoelectric effect will increase, and it is depicted by this diagram. Now second one is again very important, where see we are using three graph in one line, in one diagram. Here the frequency is kept constant. Light of same frequency has been applied, but different intensity. Frequency is constant, but different intensity. One intensity, second intensity, and third intensity. Am I right? So you see, with different intensity, the current will be more. More the intensity, more will be current. So you will get I3 is greater than I2 is greater than I1. And here there is one point, it is cutting potential, because it has got a constant frequency. Each and every one, basing upon this constant frequency, it will have a single cutting potential or stopping potential. Hence that has meet up in a single point. It is the stopping potential point or cutoff potential point. So this is the variation where we have seen that when light of constant frequency is fall upon the metal surface, utilizing different intensity, we have got different current. One current is this, other is this, other is this, and the I3 is greater than to I2, then greater than I1. Since intensity is related to current, photoelectric current. Now here in this case we are taking the example, different frequency of incident radiation is used where intensity is constant. Intensity of light, taking intensity of light constant, we are using different frequency of light. Say we are taking frequency 1, frequency 2, frequency 3, nu 3, nu 2, nu 1, low frequency, and we have assumed these lights has been fallen upon the metal surface in such a way that after a certain point this three light gives you a saturated current. This three light of different frequency gives you a saturated current. Then the frequency 1, nu 1 is greater than nu 2 and greater than nu 3. So with increase of potential, again positive potential, it increased in three cases. After certain time, certain point, it becomes 1 when it is adjusted in such a way that incident radiation is adjusted in such a way that the three light of different frequency gives you a saturated current. The graph will be like this. Here I have taken another example where stopping potential versus frequency I have drawn, and I have taken two types of metal, metal A and metal B, where nu is the frequency of incident radiation and nu naught is the stopping threshold frequency of that metal A. Again, nu is the frequency of incident radiation, same frequency, and the stopping potential, work function threshold frequency is nu naught for the metal B. So here in the first case, metal A has incident radiation is more than threshold frequency nu naught of metal in metal A, and here incident frequency is more than threshold frequency in metal B, V naught. Am I right? Now, if you say, if you find in this way work function, that work function, since you see this much is the frequency of in case of metal A, and that much is the frequency of metal B. So stopping potential is B naught and B naught 1. For metal A it is equal to this much and metal B is equal to this much. For clearly metal B has bigger stopping potential, and that's why we know work function equal to h nu naught, where nu naught is the more, then work function will be more. So here nu naught is the more for metal B, so metal B has more work function than metal A. It is for B, it is for A. It is another type of question very often asked in exam or in entrance exam. So before coming to photoelectric emission, photoelectric effect, Now let us first touch upon laws of photoelectric emission. What are the laws? The first law is that on when you will fall, you will made to fall the light radiation, and if the light radiation, the intensity of light radiation is more, the number of the photoelectron ejected will be more. Means more and more photoelectron will fall upon or strike upon the surface of the metal surface, and more will be the kinetic energy of the electron upon the surface of the metal. Number two, beyond the threshold frequency, maximum kinetic energy of the emitted electron is independent. Number three, there is a minimum of the frequency of incident radiation below which no electron will be emitted. Am I right? Hence, this frequency of minimum frequency of light is called threshold frequency. And the last one is the photoelectric emission is an instantaneous process. That is, upon the falling of the photoelectric light, instantly the ejection of the electron will occur if the light is of suitable wavelength, and the time lag between the incident of radiation and emission of electron is 10 to the power minus 9 seconds. So it is a very instantaneous process. I will try to explain the photoelectric effect in a very precise and concise manner, in a very short manner, and this point is very important for exam point of view, because a lots of question very often asked from this point, and also basing upon the formula, a lots of problems are being asked from this topic. So the explanation upon the photoelectric effect will be very short, and I hope you can understand very easily. So you see the metal, this I have drawn roughly the metal, and metal surface I have shown you some electron, one or two electrons, and these electrons are bonded to each others. Am I right? A lot amount of with some amount of energy with which it is bonded. Am I right? So what's happened when light of suitable wavelength, is made to incident, or radiation of suitable wavelength is made to incident upon the surface of the metal. What's happened? This amount of light, that is nothing but energy, some amount of energy has been given upon the surface of the metal. As soon as the energy is imparted upon the surface of the metal, some part of the energy is being utilized or being used, which are used to separate the bonded electron to free electron. So some bonded electron gets free electron upon the imparted radiation. So this one part of imparted radiation is being utilized to separate out the bonded electron into free electron. So as soon as the free electron is get free, what's happened? Upon the energy that will starts moving out from the surface of the metal with some amount of energy or speed, and so the energy which is fallen upon the surface of the metal has split into two parts. One part is being used to separate out the bonded electron to make it free. Another type of energy is used to make the electron to escape out from the surface of the metal with some amount of energy and velocity, and that is called kinetic energy, is equal to half m square. So in a very shortcut way, you can say that energy supplied upon the surface of the metal is equal to h nu, and some amount of energy is used up to separate bonded electron plus and some of the energy is used to eject out the electron from the surface of the metal. Now, first type of energy which is used to separate the bonded electron is called W naught or work function, and the amount of energy which with the help of which the electron has escaped the surface of the metal is called kinetic energy. So you have got the Einstein photo equation that is given by Einstein. Photo equation is H nu is equal to W naught plus kinetic energy. Better you can write H nu naught is equal to H nu naught. H nu is equal to H nu naught equal to kinetic energy. Also you can write it another form, H nu minus H nu naught is equal to kinetic energy. Also you can write H nu minus nu naught half mv square. Again you can write twice H nu minus nu naught is equal to mv square. Again you can write twice H nu minus nu naught by m root r is equal to b. Very often in the question in the exam you are given find the velocity of the ejected electron which has escaped out of the surface of the metal. So you need not write each and everything, you just twice h root over twice h into nu minus nu naught divided by m is equal to b. With the help of this formula you can write. I have given you a lot of form 1 is this, another form is this, another form is this, another form is this. Along with the help of this you can write the for Einstein photoelectric equation. You can solve out the problem from yourself. So kinetic energy is equal to half mv square. Also we can write kinetic energy is equal to half mv square is equal to ev naught. This is another formula. Again with the help of this if you write de Broglie's wave equation, where de Broglie's wave equation you will find lambda is equal to h by mb. Am I right? So derivation is not required, but if you want to derive, you just E is equal to mc square and E is equal to h nu, and you compare these two. Mc square is equal to h nu. If you want to derive this one, so Einstein E equal to mass energy relation E equal to mc square and equal to Planck's relation E equal to h nu. So you compare these two, you will get mc square equal to h into c by lambda, where you get mc equal to h by this and equal to lambda is equal to h by p. So you will get the de Broglie equation lambda is equal to h by mb. Now again that lambda is equal to h by mb is equal to p. So here you can again derive another formula. Therefore, you can write half mb square equal to ev naught. From this, you can find mb square equal to twice ev naught. There you multiply both sides by m, you will get m square b square equal to twice m v naught. Then p square equal to twice m naught. The p equal to root over twice m e v naught. So therefore, p equal to root over twice m e naught. Now you can put this one according to the demand of the question. You can use this formula also. Lambda is equal to h by EV naught. Again, this is equal to kinetic energy, and you can write again you can you can write kinetic energy equal to half mv square, half mv square equal to e, mv square equal to twice e. Therefore, multiplying both sides by m, you will get m square, b square equal to twice m, p square equal to twice m, b. Therefore, p equal to root twice me. Now again you can find lambda is equal to h by twice me. You can write this formula. Again, very often you are asked in the exam a question, because I am giving you some the formula, because there is some part is theory part and some mathematical part, so I am giving you some scopes of mathematical part, so that in my next class I will solve out each and every mathematical formula, mathematical problem. Now you see, Einstein mass energy relation equal to mc square. We can write it equal to mc into mc into c. Now take c below, so e by c equal to mc, mc equal to mb, nothing but mass into velocity equal to momentum. So e by c is equal to momentum. So another formula, momentum p is equal to e by c. Again, if e is not given, we know from Planck's relation E is equal to h nu. So in place of h you can put e, you can put h nu. So h nu by c is equal to p. So you can write the momentum is equal to e by c. You can write momentum h nu by c. Am I right? So a lot of formulas are given in the dual nature of the radiation of the matter. Hope I have explained with the theory part of the dual nature of radiations and matters, and I will explain in the next class all the possible problems and how to solve out this problem with shortcut trick upon this one. Thanks a lot for watching the class. Hope I am coming with the new class with best and best of things and examples.